So for our next property, we're going to look at what are called even and odd functions, specifically in the context of our trig functions, where we say a function is even if we have that f of negative x equals f of x. And usually the easiest way to understand a even function, that is thinking about polynomials, where if we have a polynomial of even degree, it's generally going to be even. So for example, x squared is an even function. Meanwhile, an odd function is one where f of negative x equals negative f of x. So think something like x cubed to think of a odd function. And for the trigonometric functions, what we can do is think about this in terms of reflection over the axis. We can think about taking some point that's above in the first quadrant and flipping it below into the fourth quadrant on the bottom side. And if we do that, we'll notice that our values for cosine and secant, the x components, as it were, well, those stayed positive, even though we flipped over the y values. So, cosine and secant, because they remain positive, would, even though we made the angle negative, that is, would be even. Meanwhile, every other trig function that has a y component in it would have that y component get flipped by flipping over the angle. So all of sine, cosecant, tangent, and cotangent would be odd functions in this context. So we would have that cosine of negative t equals cosine, secant of negative t equals secant, sine of negative t equals negative sine of t, cosecant of negative t equals negative cosecant of t, tangent of negative t equals negative tangent of t, and cotangent of negative t equals negative cotangent. And next, we're going to take a quick look at how we can apply that, where if in particular we want to talk about sine and cosine at negative pi over 4, in terms of what we just saw in that last video, sine of negative pi over 4 by our design here would be negative sine of pi over 4, or negative root 2 over 2, while cosine at negative pi over 4 would remain cosine of pi over 4 by its evenness, as it were. And as a result, we would just get root 2 over 2. And then the next thing we're going to see from this is a string of our most important identities, a string of our most important pieces that we can work with when defining relationships between trig functions.